Welcome student, welcome to the YourPedia platform. Today I am also going to take one of the question of the NPTEL assignment book. Okay, this book will contain so many assignments of the provided by the IIT and faculty. So in this today I am just going to take a question of engineering mechanics. So basically I am taking a question number 35, which is on the page number 314. So try to solve this question. This question also contains some concept here. So here I am just taking the question and also define the concept, which concept are behind this. Okay. So this is our question. A uniformly loaded propped cantilever beam and its free body diagram are shown in the figure. The reaction R1 and R2 and a movement M R. So as you just see the question, this is a case of a propped cantilever beam. What do you mean by a propped cantilever beam? Okay. So first of all I am just going to define the propped cantilever beam. This is our cantilever beam. This is our cantilever beam, which is just subjected to just like a load or a UDL, whatever the things you can just provide it here. If this is supported by any supports, so this is called a propped cantilever beam. So in the case of a propped cantilever beam, what will happen? Whatever the deflection are provided at the end supports is balanced by the other one. Okay. So whatever the deflection came at the end point, this is just provided by the another support, that is this one. So what is the way to solve this question? How to going to be solve this question? So first of all I am just going to be break this propped cantilever beam into the two cases. One is a cantilever beam subjected to a UDL, and another one is a cantilever beam is subjected to a point load at their end. So we can just break this one. We can going to be break this propped cantilever beam into two cases. One is a cantilever beam having UDL, and another one is a cantilever beam which is just subjected to a one support at their ends, subjected to a load at their ends. So if I am just going to find out the reaction, let us assume this is a point number A, this is a point number B, so this is again B or A. If I am going to calculate the reaction at that point, so first of all I am just going to be calculate this one, RB reaction. So how you calculate this RB reaction? So first of all you have to just find out the deflection due to this member UDL, and this deflection is just compensated by the reaction at the end B. So try to find out the deflection at the end B. I am just going to take the deflection at the end B. This is our member subjected to UDL. Okay, let us assume this is a UDL having magnitude of Q, length per meter, Newton per meter. If I am just going to take a X from the free end, I am just taking the X from the free end. Now the movement at a section X. What is the value of movement is, that is how to going to solve the UDL. UDL is just equals to the force into distance. अब ये force में कैसे convert होगा? This is going to be converted into force, this Q into L. Now it is just going to be converted into the, here you just take the, instead of L you just take the X, because I am just going to find out the at a section Q into X into X by 2. Now I am just going to see the nature of that. This is also going to be sagging, so this is a negative sign is also came here. So the movement at a section XX equals to is minus Q X square by 2. If I am going to find out the deflection at the end free end, that is the end B, how can I find out? That is, you just write the equation d2y upon dx square equals to 1 upon EI into movement at section XX. So we are just using this equation. Now d2y upon dx square equals to 1 upon ei minus q of x square by 2. Let's going to differentiate this one. If I am going to differentiate, we are just getting the dy by dx 1 upon ei, and the different integration of that part is minus q x cube, and 3 is divided by this, so it is 6. Now plus c1. This is equation number 1. For a deflection, we are again going to be integrate this one. So now y equals to the 1 upon ei minus of q x to the power 4 upon 24 plus c1 x plus c2. This is equation number 2. Okay. For that, you have to just find out the value of a c1, c2. For c1, c2, you will just take the boundary condition. What is the boundary condition here? Boundary condition. If I am just going to see the cantilever beam, so the cantilever beam have a maximum deflection, a maximum value of a theta and y at their free end, whereas at the fixed end it is just going to be 0, and I am just taking the section xx from the free end. So now this is a point number A, this is a point number B. At A, x की वैल्यू क्या हो जाएगी? X equals to L and theta equals to 0 and deflection equals to also 0. At B, B पे क्या हो जाएगा? X का वैल्यू 0 हो जाएगा. Now theta equals to the theta max and deflection equals to the deflection max. Okay. अब now I am just going to use the boundary condition. Now I am going to use the boundary condition. Which boundary condition? This is the boundary condition number 1 at equation number 1. So equation number 1 is dy by dx equals to 1 upon ei minus q of L cube into q of x cube by 6 plus c1. This is a not L, this is a q of x cube upon 6 plus c1. I'm now use this one at theta x equals to L, theta equals to 0. So this is came to a 0 equals to 1 upon ei minus q of L cube by 6 plus c1. So here we just find out the value of c1. C1 is came to be a q L cube upon 6 ei. This is the value of c1. Now just put this value c1 into the equation number 2. Equation number 2 is this one. So y equals to 1 upon ei minus q x to the power 4 upon 24 plus c1. C1 is came to be a q L cube by 6 ei. Q L cube upon 6 e I into x plus c2. So now just again put the boundary condition at x equals to L, y equals to 0. So this is become again 0, or this is 1 upon ei minus q L to the power 4 upon 24 plus q L to the power 4 upon 6. This ei is came to be a common. Six plus C2. So if you are just going to calculate here value of this, take the 24 minus Q L to the power 4 minus 1 plus 4 plus C2 into 1 upon EI equals to 0. So from here the C2 is came to be a Q L to the power 4 upon 8 EI. Now just put the value of this again in the y equals to 1 upon EI minus Q x to the power 4 upon 24 plus Q L cube into x upon 6 and this one is again plus this one is came to be negative. So this one is again Q L to the power 4 upon 24. Okay. So now for finding out the maximum deflection at the free end, what will we do? At x equals to 0, y equals to क्या आ जाएगा हमारा? Y equals to y max. So now from here you are just getting the y or delta max at B equals to how much? Q L to the power 4 upon 24 EI. So this is a deflection at the B point. Now what will we do? We are able to find out the value of this deflection, that is came to be a delta 1 equals to Q L to the power upon 8 EI, whereas when we are just applying the load at the fixed end, that is came to be a delta 2 equals to, this is the equation B, RB L to the power cube upon 3 EI. So here what will happen? Delta 1 equals to delta 2, because this is just a reaction produced by the support. This RB is a reaction provided by the support. So from here what will happen? That is Q L to the power 4 upon 8 EI equals to RB into L cube upon 3 EI. So we are just going to be cancel this one and this. So the RB values came to be a 3 QL by 8. So the RB values here came to be a 3 QL by 8. Now again, as we know about that, ki RA plus RB equals to Q into L. So this is came to be RB is came to be a 3 QL by 8. This is RA plus 3 QL by 8 equals to Q into L. So the RA values came to be a QL minus 3 QL by 8. So that is came to be a 5 QL by 8. So now the moment, it is also asking the moment. If I am just going to find out the moment, what will happen? This is subjected to a UDL and this is a support. Now the reaction at B equals to 3 QL by 8. Okay, so this is subjected to this one QL. If I am just going to find out this one, the movement about point A, that is equals to 3 QL by 8 into the distance is L minus QL into L by 2. So this one is came to be a 3 QL square by 8 minus QL square by 2. Just take the LCM and now QL square minus 3 minus 4. So that is came to be a minus QL square by 8. So this is the movement. As you just see the option here, this is the reaction at 1 is 5 QL and reaction at B point is 3ql by 8 and the movement is ql square by 8. So I think you will enjoy this question. So this will question also contain the concept of the deflection. So there are so many questions which having the good concept, or also came into the so many examination which are directly taking the question by these types of assignments. So focus this book and just try to sharp your concept by solving the so many questions which are provided here. And we are also launching the test series which will totally contain the question of the only NPTEL assignments. Okay, thank you so much.